Okay, so we're going to complete the example that we didn't get to in class today. In this example, we have a manufacturer of high-resolution video terminals must control the tension on the mesh of fine wires that lies behind the surface of the viewing screen. Too much tension will tear the mesh, and too little will allow wrinkles. The tension is measured by an electrical device with output readings in millivolts. Some variation is inherent in the production process. Here are the tension readings from a random sample of 20 screens from a single day's production. So there are the values. Construct and interpret a 90% confidence interval for the mean tension of all the screens produced on this day. So in our minds, we want to follow the outline of state, plan, do, conclude. So we should make it very clear what our variables are and what we're going to do when we state the problem. So we want to estimate the true mean tension at a 90% level of confidence. Okay. So looking at this, the main question we're going to ask ourselves is, do we know the population standard deviation or not? We obviously don't know the population mean because we're trying to estimate it. And in this case, we do not know the population standard deviation. So when we do this confidence interval, we're going to use the t-distribution. So we're going to estimate the true mean tension at a 90% level of confidence using a one sample t-interval. It's very important that you mention the type of test you're using. That's the number one there. Okay, so there's our statement. What we're doing, what interval we're using specifically. In our plan portion, we have to think about, well, are the conditions for using this test met? And our three conditions are random, normal, and independent. I'm going to start with random and independent because normality is going to take a little bit longer to prove. Random. Well, they told us that we had a random sample going. Random sample of 20 screens. So we're given a random sample of 20 screens. Okay, and like I said, we're going to talk about normality in a moment. Let's look at independence next. Hopefully you remember that the independence condition is the same as the 10% condition. So we just need to make sure we meet the 10% condition, which says that as long as our sample size is less than 10% of the population, we're good. And so 10 times 20 is 200. And it seems reasonable to believe that at least 200 video screens were produced in a day of production. And that's what I'm going to say. It is reasonable to assume at least 200 screens were produced. Okay, so my first two conditions are met, random independence. Now we need to talk a little bit about normality. I'm just going to scroll up here so we have a little room. When we're estimating means, we either need the population mean to be normal. We need the population to be normal, or we need to have a sample size of at least 30. You'll notice in this case, if you look at your sheet that I handed out to you in class, it doesn't say anything about the population distribution. But we also only have a sample of size 20, okay? So what you need to do is check whether it's reasonable to believe that the population is normal, meaning you should look at some visual display of the distribution and ask yourself, well, is there anything stopping me from saying that this could be a normal population? Is it strongly skewed? Are there major outliers? Okay. Since n is less than 30, we need to look at some kind of visual display of the data. Look at the distribution of sample data. So some options you have are a dot plot, a box and whisker plot, okay, something like that. And so what you'll need to do is plug the data into your calculator. Okay, so I plugged the data into my calculator and I got an image of the box plot. And what you're going to need to do on the AP exam is it's not enough to just say that you looked at the box plot and it looks approximately normal. You will actually have to sketch the box plot or the dot plot yourself and provide that visual proof. So I'm going to insert an image of what my calculator showed, and then I'm going to copy it using the trace function. Okay, so there's the image that my calculator provided. And now I'm just going to use the trace function to make a scale, okay? And the units of my problem were millivolts, I think. My smallest value is 233.5, so I don't know, I'll say 230 down here. My biggest value is 374, so I'll go by 30s, why don't we say? So 260, 290, 310, 340, 370. Okay, so my smallest value I said was 233, so maybe that's here. Quartile 1 was at 275. Quartile 2, which is the median, is at 308. Quartile 3 is at 337. And the max value is 374. So we have our box and whisker plot. Okay? And so what you're going to say, this picture didn't move with it, I'll move it with it. What you're going to say is that the box plot is not skewed and there are no outliers. Since the box plot isn't skewed and shows no outliers, we don't doubt the normality of the population. We don't doubt the normality of the population. Okay, so we've checked our three conditions: random, independence, normality. Most often for the normality condition, you'll either be given a fairly big sample size or you will be given that the population distribution is normal. Generally, you only have to go through this procedure if they give you the actual data and there's not a lot of it. Okay, so in this case, there were only 20 pieces of data, but thankfully we can use our calculators to help us see the box plot and graph it quite quickly. Okay, so that's the hard part. The planning is always the most difficult part. Finding the actual interval the confidence interval, is quite easy. So that's what we're going to get to next. So I'm going to scoot forward. And I'm just going to start over again. Okay, the previous page was my state and plan, and now we're going to do. So remember, confidence intervals are the statistic plus or minus the critical value times the standard deviation. Now in this case for us, since we're estimating the mean, our statistic is the sample mean. Since we're estimating the mean and we don't know the population standard deviation, our critical value is t star, and our standard deviation is the sample standard deviation divided by the square root of n. Well, these values are very easy to find, okay? And on the side here, I'm just going to write what they are. We can find the sample mean and the sample standard deviation using one variable stat on our calculator. So you would go to Stat, Edit, Calc, and one variable stat. And it tells you that x bar is 306.32. It tells you that the sample standard deviation is 36.21. We know our sample size is 20, and we get t star using degrees of freedom 19 and a level of confidence 90. So we go to table B. I'm going to go do that right now. In the back of our book, and we go to degrees of freedom 19, and we go across until we get confidence level 90, and I get that t star is 1.729. If you have questions about this, you can email me. And we fill in the blanks here and simplify. 306.32 plus or minus 1.729 times 36.21 over the square root of 20. And 1.729 times 36.21 divided by the square root of 20 is about 14.00. So 306.32 plus or minus 14. And we get a confidence interval of 306.32 minus 14, which is 292.32, to 306.32 plus 14, which is 320.32. And that's my confidence interval. The last thing we need to make sure we do is conclude our work. So I'm just going to move up a little bit. Okay. We are 90% confident that the interval from 292.32 millivolts to 320.32 millivolts captures the true mean tension of the terminals produced that day. Okay, and we're done. We stated what we were going to do and what type of test we're using, a one sample t interval. We planned by checking our three conditions. In this case, the normal condition was a little more complicated to check. Then we performed the calculations to get our interval, and then we interpreted our interval in the context of the problem. So this is what one sample t-intervals are like. Okay, and again, we only use one sample t-intervals when we do not know the population standard deviation. So go ahead and try this homework out that is up on the website for Wednesday, and feel free to email me if you have any questions whatsoever. Thank you.